let's go ahead and take a look at our very first algorithm we're going to talk about. We talked about the theory last time. Let's take a look at the actual programming. Let's take a look at the notion of factorial. You recall from the video last time, factorial n factorial is equal to n multiplied by n minus 1 multiplied by n minus 2, and the I guess you could say halting or terminating condition is when n equals 1. So if, for example, n is equal to 5, n is equal to 5 times 4 times 3 times 2 times 1, and then it will terminate. So that's approaching essentially. Why is it that the margins, the spacing here is so different? Let me go ahead and hopefully change that. Remove. Okay, there we go. And so that's going to be something like 20 times multiplied by 6. What is it with Microsoft and Word and all the dots? So that's a 120. So just to prove that is the case. So obviously we could go to our Python computer, or excuse me, go to our computer, and in Python we can literally type print this, and it would yield 120, but that's not an algorithm. We need to create a program that says that whatever number that we select, it's going to be subtracting 1, and then subtracting 2, and then subtracting 3, or however way you want to do it until n equals 1. So the question is, how can we do that? So what is the first thing that comes to mind? That something has a lot of repetition until a certain condition has been met, and of course that's the while loop. So we could say something like while n is greater than 1, we could say n is equal to n multiplied by n minus 1, and then in order for us to avoid an ongoing loop, we would actually have to say n is going to be decremented by 1 each and every time. So how does that translate to actual Python code? Let's take a look. All right, I highlighted the word factorial so you can make better sense of this. So here is the initial formula right here, and here's like our weird pseudocode, and here's the actual code I came up with. So the first thing we did is we'll test the base case. Now take a look here. Now imagine if x equals something more substantial, like 8. And t equals 1. So I make these as simply reference variables. And I know there's probably a better way to do this, a more Pythonic way, I understand, but this is where, we're learning right here. So these are reference variables, x equals 1, t equals 1, and while x is greater than 0, so in other words, we're establishing a termination point, print x. So what we're doing here is I want to keep track of what is happening with x. So a lot of times when you first start out programming an idea, you want as many print statements as possible to track your progress. So if you would indulge me, and let me go ahead and put in my faux password right here into my Kali. So if you were wanting to really test out your program, a lot of times you would want to put in a number like, as I said, 8. Let me do that. And the print x allows us to see what is going on with x as the while loop, I'm going to say, iterates. So let's go ahead and run factorial, Python 3 factorial, and of course we do see 8 becomes 7, 6, 5, all the way to 1. That's when it terminates, and we wind up with a factorial of 40,320. Now let's go back here and let's do our base case. Base case, of course, is 1, and let's run our base case, and that is 1, but let's go ahead and almost run a recursive type case. So let's say 2, and let's run this. Okay, 2 times 1 is equal to 2. Now let's do something quite ridiculous. Let's say 2,000. Now imagine having to calculate that. I don't even know that this is going to fly. Let's see what happens to my processing power on my virtualized OS. And okay, it as you can see, value, here, let me move this over. Value exceeds the time limit. So would that have changed if this is bare metal? This Kali was bare metal, meaning you installed it directly on your laptop, maybe. But let's be safe here. Let's do 200. X is equal to 200. And let's run it. And I just want everyone to see what's actually going on here. That what it's doing is, sorry, I'm going up when I should be going down. So it's starting at 200 and it's doing 200 times 199 times 198, 197, and so on until we get all the way to 1. In the same vein, that if we did 8, change that to 8, it's going 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is 40,320. And what's the one that we did in front of you? Let's do 4. Actually is equal to 4. 4 times 3 times 2 times 1 is actually 24. So we know it is working. Look at the Fibonacci sequence now. Let me go ahead and make it so that it's more legible. So the Fibonacci sequence, here are the first 20 or so numbers of the Fibonacci sequence. So for example, we have 8, and 8 is the sum of the two preceding numbers 3 and 5. 5 is the sum of the two preceding numbers 2 and 3. 2 is the sum of its two preceding numbers 1 and 1. 21 is 8 plus 13. 34 is 13 plus 21. 55 is 21 plus 34. So I hope everyone is understanding the pattern right here. Of course, the very first things to kick us off is 1 is equal to the pattern of 0 and 1. So this is really, if you can understand how this pattern can be created from an algorithmic point of view, you pretty much have programming itself licked, because this is probably one of those gotcha questions that they would ask you in a programming technical interview. By no means does it represent the only one or the main one, or it might be like a beginning one. But if you go ahead and look at LeetCode.com or whatever it's called, it goes over the interview questions, past interview questions, and I guarantee this is going to be one of them. 987 plus 1597, I'm sure, don't even take your calculator out, because you know that it's going to equal to 2584, and so on and so forth. What would be the next number in this sequence? Can you guess? It would be the sum of these two numbers, whatever it is, somewhere around 6 or 7,000. Now, how is a computer able to decipher this pattern, and how would it guess the next number of 2 and 3 would be 5? Well, it would say n equals n minus 1 plus n minus 2. What that means is the current position is equivalent to the last position and the position prior to that, whatever it is. So if 610 is n, then n minus 1 is 377 and n minus 2 is 233. You add those together and you get n. What does that mean in terms of syntax? Let's take a look at this. Let's make this a little bit smaller so it fits nicely on the page, and let me put it like you might read it as a computer might read it, Courier New, and maybe put it in bold and maybe make it even smaller. There we go. So hopefully you can see this. List.append list next is equal to list current position minus 1 plus list current position minus 2. So that might be how you would arrange it on your computer. Now, if you can't see this, I could make it maybe a little bit bigger. I'll just make it a lot bigger so you can kind of just see this. Okay, so list.append equals list next equals list current position minus 1 plus the list of indexing current position minus 2. So what does the actual code look like? Meaning, if I were to ask you to put the first n Fibonacci numbers in a sequence, could you do that? So let's see the code of how you could possibly do that. For the Fibonacci, I wrote a little program right right here. So we have a reference list, L1 equals an empty list, and then I say for I in range, and I did 100. Let's check out Kali itself, and I did 100. I changed it to 20. So if we go back to this, so for I in range 20, and the idea of an algorithm is that you have to address each and every possibility. So if I equals 0 and this happens, you append I. So at the range, if you just print I in range 20, this is what happens. So let's go to Python 3. Hopefully you're seeing this. And let's say we said print range 20 and we get range 0 to 20. But if I said for I in range 20 and I said print I, comma, end equals this empty space right here, we would get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way to 19. So what happens is when we say for I in range 20, we start at 0, and it says if I is equal to 0, we are going to go ahead and append 0. And what will happen with the range command, it will automatically increment to 1. So elif I equals 1 will also append that. Else, and that is anytime it iterates past 1, which is the next iteration is 2, it'll say append L1 I minus 0. So that's the index of L1. And we already established that L1 minus 1 would be 1 because so far the list only has 0 and 1. And then I minus 2, the position, the index is 0. So the next one will be 1, and so on and so forth. So this is actually the result of that. Let me exit out of here. Okay, let's run fib.py, and the first 20 numbers or so of the Fibonacci series or sequence is 0, 1, 1, 2, 3, 2. So 2 plus 3 equals 5, and that goes in line with our call to create the sequence here. Append the sequence of append L1 in index, the index prior to that, and that's the sum of the index prior to that, and the sum, this is the sum of the index prior to the existing L1 and the 2 positions away. So take a look at this and let it and mull it over, I guess, in your head and get to know this code right here. Even punch it in yourself. Okay, one last algorithm or one last problem solved before we go. Use the Python list method sort to find the max value of any given list. So if you please take a look here, if we have this random list I put together, x1 equals 45, 12, 23, 89. One thing about the sort method that we know, and I did a x1 dot and then press tab twice, and then you wind up with x1 dot sort. So once you run x1 dot sort, it sorts it in order of least to most, and the highest value is going to be the final value or the rightmost value. And just so you know, you can get whatever number of items are in the list. You don't have to say the third item in the list, which would be the index of the third offset, which would actually be the fourth item starting at 1, but because offset starts at 0, it would be the third offset. So x1 of the length of this list. Now keep in mind, len of x1 is going to be 4, so the fourth index minus 1, or the fourth index is actually numerically 4 minus 1. That will yield your 89. So you might be able to take a guess about how you would utilize the sort to find the max value of any given list. So you may create a while loop. So while ref variable does not equal 0 or something, and then you might say that the user enters in you offer the screen to say input these values in this list until the user enters 0. So the user can enter in any amount of values, and we know that to calculate that n value, you would always be that n value is x of len x1 minus 1. So there's your clue.